Alright, here we go. Statistics 8.7. It's all about simulations, so you want to make sure you have some internet capabilities, because there's some great websites, which is actually on the homework, that can help us do a lot of this stuff. Okay, so the first one asks us to go to this website here. Now, if you go on that, obviously you can't click on it because this is a video, and unless you go, I guess, download this version of the homework on the website. But there's a link on that page that will take you to a newer one. So let me pull that link up. So right here, this is a link that will help out with that. So you can actually do this instead of taking a coin and flipping it 5 times, which, as we can remember in class, we had that issue with them seeming to be a little landing on heads way too much, those 4 coins that I had. So you can just have it do it 25 times together instead, and that's what I did. So let me pull that up. So this is kind of the website I used. So it shows you kind of the simulation that it's got, what they were, okay, tells us a lot of stuff. And actually, this is really that table that you were supposed to fill out. That's kind of how you can do that. Okay, so we had, let's see, so yeah, let me just pull up my table. So that told me that I had 2 at 0%, no heads. We had 3 with 1 head, 3 times. We had, let's count them, 1, 2, 3, 4, 5, 6, 7, 8. I guess I should just write the number instead of put tally marks, huh? Then we had 10. Then we had 1 and 1, which that gave us 25 total, right? Okay, now this right here is actually what we needed for the next part, right? Wants you to draw a frequency table, a histogram. So that's what we have. So I actually showed you twice because you may have different results than I did. Okay, so here's the 2 ones that I did. Now if we look at this, you hopefully can kind of see we've kind of got what appears to be a normal curve kind of going on, doesn't it? Okay, so our shape and our spread, obviously, between the 40 and 60%, we have the most, and then a few less out here, and then further out, not as many, right? Kind of a similar. This one skewed a little more down, this one skewed a little more up. But the shape is a fairly close to normal curve, I guess you could say. The center is right around the 40-60%, which would make sense. And then the spread, is about that. It just kind of goes out to the left and right with a bunch, less frequency. So kind of that normal curve, we could say, with that spread. All right, so now the next one wants us to do 20 coins. I think it wants us to do 20 coins at a time. So once again, use that same simulation, and that's what I did. So let me show you what I got. Okay, so here we go. So for our frequency table, okay, we didn't have, so 0%, I didn't have any. 10, 5, 10, even, I had 0 on all of these ones. And even at 20, I had 0. You may have some of those, because it could, the more times you do, you can do it over and over. You can see how much you have. So at 25, it happened once. At 30, 35, then 40 was 3, 45 was 4, 50 was 4, 55 was 4, right? 55 right there. 60 was 2, then 3, then 1, 0, 0, 1, 0, 0, 0. Okay, so that was when I did it with 20 coins at 25 times. Okay, so that's kind of what we see. So once again, it wants us to talk about that. So how does this one look? Well, once again, the majority is falling in between that 40 to 65 range. So my center, is pretty close to around 50, maybe 55%. And that spread, it's not going too far beyond there, is it? Okay, so it kind of still, maybe not as much, but kind of looks like it has some sort of curve going to it as well. Okay, so when we compare the two, what do we know? Well, going back here, okay, that one seems to be more of a normal curve, doesn't it, than this one. This one seems to be not as high. About the same spread, right? But kind of similar, slightly different. So your distributions might be slightly different, so just talk about those differences. For mine, they're pretty much the same, except I think mainly that height. The spread looks pretty similar. The center is pretty similar, but that shape isn't quite as high, and it's more of them we see here, but that's because you're dealing with more coins. So now it says, if you repeated the process with 500 flips instead of 5 or 20, predict what would happen to the shape, spread, and center of the new histogram. So this is what I got when I did, this one. I did it over and over and over until I got up to 500 times. And if we look at that, see now look, this is clear up to almost 90. But I think this one, really we can see that bell shape going here, right? So if we were able to, and I actually think I took a picture of the histogram with if you click right here, it'll give you the standard deviation and the mean, which I should have been doing on all the other ones, but let me find that. Yeah, here we go. See this one, we've got our mean, which is what we'd expect, right? Because the theoretical probability is 50%, 50-50 for a coin toss. Notice how close that gets to 50. Whereas I bet if we looked at our other ones, they'd be slightly off. Okay, and then a standard deviation of 0.1. So that tells us that, if we're looking at this, standard deviation of 0.1, so starting about 50, that one standard deviation would be 40 to 60, which is what we see in all of our other distributions. That seems to be the most where things are, which is that's a little over 68%. Then if we go further out, another about 0.1, okay, that's 95%, which makes sense because we can see there's not much. So if we go 3 distributions out, that's pretty much covering everything, right? That's our 99.7%, okay? So you can see that the more repetitions to do, the more normal of a curve we get when we're looking at that. So that shape and that spread follows the normal bell curve. Alright, so then they're kind of talking about that let's make a deal. We've got another website. If you go to this one, you have to look down. It's called Sticker Switch. Okay, that's the one you want to look at. And you can play the game doing that. And I kind of took some screenshots of that one as well. So let me pull those up and we can kind of look at those. And then talk about the probability in that. Okay, so looking at these ones, you can do it one at a time, where you pick some doors, and then you can either hit stick or switch, and then it'll kind of just take it through. So that's what I started. Alright, so you can do it that way, or you can hit multiple games, okay, which is a lot easier. Then you type in the number, what you're doing, and it'll calculate it for you. Yours might be slightly different, so yours may end up with some different numbers. So when we talk about for stick on mine, the wins were 8. Wow, apparently I can't write. Let's try to make that a little bigger. So 8 wins, 12 losses, so a total of 20. Okay. Then for the switch, we had 20 games again, so a total of 20. This time we won 15 and we lost 5. So my total number of games played were 40. We lost 17 times and we won 23 times. Okay, so get rid of these now. Okay, so we've got that. Now let's talk about the probability. Okay, so the probability of winning with stick. Okay, so if we're talking about all 40 of these, we take winning over the total numbers. Okay, if we're just talking about when we stuck, that was 8 over a total of 20 times, which ended up being, I think what was even said on our picture, 40%. So the probability of winning with sticking would be 40%. Okay? Let me just grab my calculator, double check that since I already erased it, but I'm pretty sure that's what it said. Okay, so yeah, 0.4, which would be 40%. Okay, for winning with switch, so we won 15 times, would be 15 over 20, which you could reduce, but we don't need to because we want the decimal or percent, so 0.75 or 75%. So a 75% chance in my games, yours might be slightly different, that you would win with switching, and a 40% chance that you would win with sticking. So then it says simulate 100 games. Okay, so and then we're going to use that to help us figure this out. So let's well, not that one. Sorry if it sounds like I'm cutting myself off. I'm hitting the add a new image, and sometimes I haven't finished my sentence when I'm talking about it. So here we go again. Oh, by the way, I actually switched and did alternate, and this is how we ended up. 55 and 45. If you were just curious and you did the same thing. So here I did the same thing with the multiple games 100 times. So notice now that our winning was 38, so it ended up being 38% on sticking, so slightly lower. And when we switched, that one also went down as well, our winning percentage. So that percent of that total games. Okay, now looking at 12. For your two-way table in problem 8, create a Venn diagram and a tree diagram below. Okay, so we've got this Venn diagram here. So now we're going to talk about using this Venn diagram. Now, since we're talking about sticking, okay, one of these circles needs to be sticking, and one of them needs to be winning, okay, because that's kind of what we're talking about. So we have stick here. So in ours, we look at this. So we won 8 times. So if I'm looking back here, this would be 8. Oh wait, no, not sticking. Winning would be 8 times. Okay. Okay. So actually, I think we need to think about this a little differently. So we're talking about stick, so yes, one of these would be stick. Okay. So that would be 8 times. Winning, however, total, we won 23 times, right? So this would be 15, right? Because 15 plus 8 would give us 23. Now sticking, when we didn't win, that was 12. Here we go. That's making more sense to me now. Okay? And when we didn't stick, that would be out here. Okay, so a total of 40 times. We're kind of combining them, though we're only really talking about the sticking. So, P of winning would simply be how many times did we win over the total, which would be 23 over 40, okay? Which would be, percentage-wise, that's 0.575 or 57.5%. Okay? Now, winning and sticking, okay, when you have this U shape like that, it means it's not included. So now what about winning without sticking? So that would be the 15. So it would be 15 over 40. Okay? Which I think, no, we didn't do it for that. It would be 0.375, so 37.5%. Now 15 is winning with sticking, so that would include all of them. So it would be all, nope. It would just be this one. Sorry, it's been a while since I've done probability stuff. So this is kind of review for me as well. So that would be in the middle, okay, when we're winning and sticking together, okay? So that would be 8 over 40, which would be 0.2 or 20% chance. 16 is losing when we're sticking, so that would be the 12. So that would be 12 over 40. So 12 divided by 40 would give us 0.3 or a 30% chance. And then winning or losing, okay, since it's the or, that would include all of this, so they all add up to, well, winning or losing would include everything. That would be, we're either going to win or lose, right? So it'd be 40 over 40, so you have a 100% chance that you're either winning or losing because there's only two choices, winning or losing, okay? So there's kind of some probability review. It's more of a math 2 thing, so if you kind of got lost there, that's all right. But there we go.